Good afternoon, everyone. Am I audible to you? Can you hear me?
Hello, sir. Yes, we can.
Okay, fine. Welcome to Indira Gandhi National Open University, and you are all the learners of BCOM. And I am your academic counselor. I will be guiding you how business mathematics and statistics, that is BCOC 134, will be made easier for you to understand. And I hope everyone has paper and pen with you because we will be talking about mathematics. So, mathematics, as far as mathematics is concerned, pen and paper is must for it. This is Business Mathematics and Statistics BCOC 134, and we have two parts in it, Part A and Part B. Part A is Business Mathematics, and that starts from matrices. Unit 1 is Introduction to Matrices. Unit 2 is Determinants. Unit 3 is Inverse of Matrices. And Unit 4 is Application of Matrices in Business and Economics. Now, the thing is that what we will be doing in matrices. First of all, it is Introduction to Matrices. We will discuss the concept. What are the different types of matrices? Matrix algebra, transpose of matrix, and its calculation. Unit 2 is Determinant, where we will be finding the value, its properties, minor and cofactors, and the application in Cramer's rule, how to solve linear equations. Then, inverse of matrices, which consist of its properties, computation of methods for determinant and adjoint, elementary operation, inverse and rank of matrices, and system of equations. There we will be using a formula. And then the application of matrices in business and economics, where we will be discussing about the application and use of matrices for business and economic decision making. My screen is visible to you. You can see the screen.
Yes,
Yes, sir. We can see.
Okay, fine. So we will start with introduction to matrices. Now the question arises: what is a matrix? Matrix is an arrangement of numbers into rows and columns. Because of its feature of compact describing sets of data and efficient method for manipulating data sets. It becomes a solution to problems which can be represented in linear equation systems. Economics and business, sociology, statistics, physics, medicine, and information technology. For a better understanding of the application, we consider the following examples. Businesses, they take the help of matrices for fast and accurate in decision making in the areas like evaluation of customers' preferences to produce and sell. Some use linear programming techniques that is based on matrix formulation, of data to maximize profit and then plan production or availability of raw materials. The last part we will see to it, how this matrix is used. Use also is made of the matrices to arrive at a decision on the location of business, marketing of the products, or arranging financial resources. Economists use matrices to examine inter-industry flows, for studying game theory, and to construct the system of social accounting. Learners, I just want to know one thing. Are you comfortable with English?
Yes, we
Okay,
are.
that's great. Okay, that's great. In how it is used in medical studies, scientists use data in matrix form to determine a statistically valid rate of efficacy of a drug before prescribing it in a hospital and pharmacies. Many IT companies also use matrices as data structure to track user information, performance, search queries, and manage database. Now, this is how matrix look like. Matrix is a rectangular array of m cross n numbers arranged in m rows and n columns. Rows are horizontal and columns are vertical. Now the thing is that this is a row. You can see four rows over here. These are the four rows. And these are the columns. This A11 represents element of first row and first column. Always remember the number, first number is for the row and the second number is for the column. Now if we take this number A23, that means second row, third column. And the general term is AMN, mth row, nth column. What are the different types of matrices? Row matrix, a matrix which has one row is a row matrix. You can see one row. Horizontal is a row. So these is a representation for a row matrix. And for a column matrix, you will have only a single column. Number of rows can be any, but vertical line will be a single line. It is represented by m cross 1. And as far as row is concerned, it is written as 1 cross n. Now, square matrix. I know you might be knowing what is a square. Square is a four-sided figure which has all four sides equal. That is why you can see here also the number of rows and number of columns are equal. Where in a matrix, where number of rows and number of columns are equal, that is a square matrix. It can be a 2 by 2 matrix. It can be a 3 by 3 matrix. This is a 4 by 4 matrix. Diagonal matrix. Diagonal matrix is a matrix in which all the elements are present in the diagonal form. This is the diagonal. And remaining all other elements are zero. This is a matrix that in the diagonal you have numbers. Number can be any number, but apart from this diagonal, all other elements will be zero. This is a diagonal matrix. Scalar matrix. A scalar matrix is that matrix in which in the diagonal all the elements are same and rest all elements are zero. You can see in the earlier one you were having different numbers. That was a diagonal matrix. And here you can see the numbers are same. That means if we take -3 common, You will get 1, 1, 1 everywhere. Rest, all the elements have to be, that is a scalar matrix. Now comes identity or unit matrix. Identity or unit matrix is that matrix in which the diagonal elements are 1 and remaining all other elements are 0. Is that clear?
Yes,
Have you,
yes.
if you have any problem during our conversation, just raise your hand and ask the question. Don't keep it for the later part. As soon
Okay.
as, because
Okay.
I will be, that will be great for both of us to understand the subject. For me, it will be easier to explain to you, and it will be easier for you to understand the concept.
Mhm.
Whenever you have any problem, just let me know. We will solve it. Now, this is an identity matrix.
Yeah.
Null matrix. Null matrix is a matrix in which all the elements are zero. Then comes your equal matrix. Equal matrix is that matrix in which number one, first condition is all they are have to be of the same order. If you have four elements in the left hand side matrix, so then four elements have to be there in the second matrix, and then only the corresponding elements are equal. Now, now we will come to matrix algebra. We will start with equality of matrices. Two matrices are equal if the following three conditions are met. Number one, each matrix has the same number of rows. Each matrix has the same number of columns. That means they have same number of columns and same number of rows. And the corresponding element within each matrix are equal. Now the question arises, what is actually meant by this? So you can see there are two matrices A and B. A is a 2 by 2 matrix. It is a 2 by 2 matrix because it has two rows and two columns. And similarly, we have B, which has two rows and two columns. Now the question arises, if matrix A is equal to matrix B, then we have to find the value of X and Y. Okay, you can see that if we start with the first element and the first element of matrix A and the first element of matrix B, you will see that both have 2. Now, diagonally you can see that there is 3 in the matrix A and 3 in the matrix B. We have to find the value of X and Y.
Yes.
So X straight away will be equal to 3 and Y will be equal to 4.
Oh.
Okay, now how addition and subtraction of matrices is performed. Now we have to be very clear that whenever we have to add or subtract two matrices, three matrices, they have to be of the same order. What is the necessary condition for adding and subtracting matrices is that they should be of the same order. We have two matrices. These matrix A consists of two rows and three columns, and matrix B consists of two rows and three columns. First condition is satisfied that they can be added or subtracted because we will be starting with adding. So they can be added because they are of the same order, 2 by 3. Now we have to add. When adding is done, The first element of the matrix A will be added to first element of the matrix B. You can see that 0 is will be added to 7. Similarly, 2 will be added to 3. Similarly, 3 will be added to 5. In the second row, 2 will be added to 5, 1 will be added to -1, and 4 will be added to -3. Once this is performed, you can see that 0 plus 7 is 7, 2 plus 3 is 5, 3 plus 5 is 8, 2 plus 5 is 7, 1 minus 1 is 0, 4 minus 3 is 1. This is addition of matrices, yeah, or addition of two matrices. Is that clear? If you have any doubt, just let me know.
Yes, clear. So
Moving further, now we will be subtracting. Same question? No. Here, A is this 0, 2, 3, 2, 1, 4, and your matrix B is 7, 3, 5, 5 minus 1 minus 3. Now we will be subtracting. That means each element of matrix A will be subtracted from each element of matrix B. A minus B will be 0 minus 7, 2 minus 3, 3 minus 5. In the second row, it will be 2 minus 5, 1 minus minus 1, 4 minus minus 3. That will be 0 minus 7 will be minus 7, 2 minus 3 will be minus 1, 3 minus 5 will be minus 2, 2 minus 5 will be minus 3, 1 plus 1 will be 2, and 4 plus 3 will be 7. This is for addition and subtraction. First condition is that they should be of the same order. Now, there is a different rule for multiplication. If an element is multiplied by a scalar, suppose lambda, so each element of it will be multiplied by that element lambda. Now we see to a problem that A, matrix A is in front of you. That is 7, 3, 5, 5 minus 1 minus 1. You have to evaluate 3A. This is the exact form how it is written 3 times of matrix 7, 3, 5, 5 minus 1 minus 1. That means now each element, we have 6 elements. All these elements will be multiplied by 3. So 7 into 3 will be 21, 3 into 3 will be 9, 3 into 5 will be 15, 3 into 5 again will be 15, 3 into minus 1 will be minus 3, and 3 into minus 1 will be minus 3. This is multiplication of a matrix by a scalar quantity lambda. It is that each element of the matrix will be multiplied by that scalar. Now, what are the properties of addition of matrices? If we have to add two matrices, they are commutative in nature. That means that is that much simple. If you will add A plus B, it will be similar to B plus C. As in the case 1 plus 2 is equal to 2 plus 1. Addition of matrices is associative. That means if you will be adding A plus B first and then you will be adding C, that will be equal to A plus the sum of B and C together. This is the basic form how it is written. Now, existence of additive identity. It is very much clear that if you are going to add 0 to any number, you will get the same number. That is the same thing. It is also applicative in matrices. If you are going to add null matrix to a matrix, you will get a matrix. The fourth property is existence of additive inverse. If you have a matrix A, its additive inverse will be minus A. When you will be doing it, A minus A will be 0, And if you have a matrix minus A, its additive inverse will be plus A. Again, when you will be adding, you will be getting 0. Now we will see two different properties. What actually, exactly, this what we have seen or learned, how it is applied. You have three matrices A, B, C, and you have 0 as the null matrix. Initially, what we will be doing, we will be adding A plus B. If when we will be adding A plus B, so it will be 1 plus 5, 6, 3 plus 1, 4, 5 plus 3, 8, 5 plus 6, 11, minus 1, minus 1, minus 2, minus 1, plus 2 will be 1. This is what you got. Now I will be adding this to this. That means I will be saying now 5 plus 1, 6, 1 plus 3, 4, 3 plus 5, 8, 6 plus 5, 11, minus 1, minus 1, minus 1. That will be plus 2, minus 2, and 2 plus minus 1 will be 1. Now you are getting this. These two matrices are here. That means the first property was A plus B will be equal to B plus C. Now you have seen it. Now we have three matrices taking 2 at once. A plus B is this 6, 4, 8, 11 minus 2, 1 will be added to 6, 1 minus 7 minus 2, 0, 5. This is A plus B and this is C. Add it. You will get 12, 5, 1, 9 minus 2, 6. Now what we will be doing, we will be taking B plus C together. So B plus C together, this is B and this is C. When you will be adding them, you will be getting 11, 2, minus 4, 4, minus 1, 7. This is B plus C. Add A to it. This is A. Add to it 12, 5, 1, 9, minus 2, 6. Here you get this and this. Both are same. Is that clear?
No, can you repeat it?
Definitely I can and I will. We are into the second property of the matrices. That is A plus B together when added to C. Their sum will be equal to A and the sum of B plus C. Now we have a matrix over. You can see over here. If you have a pen and paper, then write matrix A, B, and C.
I did already.
Now, initially what I will be doing, I will be doing A plus B. I've done it over here, A plus B. This is this. To this matrix, I will be adding this one. Here you can see. This is A plus B and this is the C. I will be adding. When I will be adding, so what I will be getting? 6 plus 6, 12. 4 plus 1, 5. 8 minus 7, 1. 11 minus 2, 9. Minus 2, 0. Plus 0, minus 2. And 1 plus 5, 6. This is what is A plus B plus C. Now what I will be doing? I will be adding B and C together. Adding B and C together, this is B, this is C. I got B plus C. As 11, 2, minus this sum of B plus C has to be added to A. So first of all, we will write A, then B plus C. The sum of B plus C, which is calculated over here. So when I will be adding them, so I will be getting 12, 5, 1, 9, minus 2, and 6. This is what I got. This is similar to what? This is similar to this one. A plus B plus C.
Yeah.
This was your property number 2. A plus B plus C is equal to A to the A will be equal to A plus B plus C. Second property. Now I will be moving to third property. That was A plus 0. I said 0 is a null matrix. That means all the elements will be 0, and that has to be similar to the order of matrix A. Your matrix A is a 2 by 3 matrix. That means 2 rows and 3 columns. You will be adding 0 to it. When you will be adding 0 to any number, you will be getting the same number, and that will be similar to your original matrix. This is your original matrix. When you are adding 0 to this matrix, you will get the original matrix. Now, to the additive inverse. This was your original matrix. I am multiplying every element with minus 1. So this will become minus 1, minus 3, minus 5, minus 5, 1, and 1. When you will be adding these two, you will be getting 0. Minus 1, 1 minus 1 is 0, 3 minus 3 is 0, 5 minus 5 is 0, 5 again 5 minus 5 is 0, minus 1 plus 1 is 0, and minus 1 plus 1 is 0. That means all the 6 elements will be 0, which is equal to 0. Is this clear?
Yes, thank you.
Now comes negation of a matrix. And negation of a matrix is denoted by minus A. We have just seen it, which is now the thing is that how it is obtained. If you have A matrix as 1, 3, 5, 5 minus 1 minus 1, what will be negative A? Negative A will be, that means you have to change the sign of the original matrix. If it is plus, it will become minus, and if it is minus, it will become plus. You can see over there. Original matrix was 1, 3, 5, 5 minus 1 minus 1, and minus A will be minus 1, minus 3, minus 5, again minus 5, 1, and 1. Plus signs have changed to minus sign, and the minus sign has changed to the plus sign. Now, if we have two matrices A and B, and we have to subtract them. So we can write it in this way. You can write A minus B is equal to A plus of minus B, because plus into minus is minus. That is not, this is basically for simplification purpose. Now, the most important part is the multiplication of two matrices. This is somewhat difficult. Easy to understand but difficult to perform, because normally error and mistakes are made in it. The requirement of multiplication if the number of columns of the first matrix is equal to number of rows of the second matrix. This is the most important part. The line what I'm telling it to you. The requirement of multiplication first is if the number of columns of the first matrix is equal to number of rows of the second matrix. If the matrix A is of order m cross n, and that means m rows and n columns, then the matrix B must be of the order n cross p, where n is the number of rows and p is the number of the columns, which is not necessarily equal to m. Condition is that the number of columns of the first must be equal to number of rows of the second. When you multiply it, that means you your two matrices, when they are multiplied, matrix A and B are multiplied, you are going to get a matrix C, and it will be of the order M cross P. Your first matrix was, listen to it very carefully what I'm saying. First matrix was of order M cross N, and the second matrix is of N cross P. Your final matrix will be of the order M cross P. We'll see how it comes. This is the manipulation mathematical indication of how it is written. If A is a matrix with element Aij of order M cross N, and B is a matrix with elements Bij of order N cross P, then when you multiply them A cross B, which will be equal to C, so C matrix will be of the order, the elements will be represented as Cij, and the order will be N M cross P. Now see to it very carefully. One of the most tedious job to be performed in this matrix, if you are able to understand it, matrix and determinant will be easier for you. Now see to it. Your matrix A is 1, 3, 5, 5 minus 1 minus 1. This is a matrix of order 2 cross 3. Okay. Your matrix B is a 3 by 3 matrix. Why it is a 3 by 3 matrix? Because it has 3 rows and 3 columns in it. Without multiplying, see how the order can be formed. I said the first order is 2 by 3. This is 2 by 3. This is 3 by 3. When you are multiplying these, that means you are multiplying these two. Your final answer will be of the order 2 cross 3. Remember this, 2 cross 3 when multiplied by a 3 by 3 matrix. Its answer will be of the order 2 cross 3. Correct? Now, how the multiplication is done. I will start, and remember, multiplication is done in this way, moving from this to this and coming top to bottom. 1 will be multiplied by 0 plus 3 multiplied by 5 plus 5 multiplied by minus 1. So what you will get? 0 plus 15 minus 5. That will be 10. Here it is. Second one, C12. Now see, I have written this. This is the answer. The order will be 2 by 3 matrix, 2 rows and 3 columns. Now this is C11. I will just put up the value over here. C12 means first row, second column. First row, second column. First row, second column. 1 into 1 plus 3 into 2 plus 5 into 2. It will be 1 plus 6 plus 10. That will be 17. Okay, you have 17 over 3. Then C13. C1 column 3. 1 into 2, 2. 2 plus 3 plus 5. 2 plus 3 is 5. 5 plus 5 is 10. It is 10. Here you get it. Now, second row, first column. So I was talking about that how the matrix multiplication is done. This is a 2 by 3 matrix and this is a 3 by 3 matrix. You can see I've written over here 2 by 3 and 3 by 3. Its multiplication answer will be a matrix of order 2 by 3. Now, how the answer will look like? That means it will be having 2 rows and 3 columns. C11, C12, C13, C21, C22, C23. This is how the answer will look like. Now the question is what will be the answer? C11, first row, first column. First row, second column. First row, third column. Similarly, we will be going for second row, first column. That will be 2 1 2 1. Second row, second column. That will be C22. Second row, third column, C23. 5 multiplied by 0 is 0. Minus plus, minus 1 multiplied by 5 is minus 5. Minus 1 multiplied by minus 1 is 1. You can see over here, it is minus 4. Similarly, this multiplied by this. 5 into 1, 5 minus 1 plus 2 into 2 plus minus 1 into 2. You will get 1. Here it is 1. C23, C2, this is 3. 5 into 2, 10. 10 minus 2 is 8. Just place these values in this order. Because you have to write your answer into this order. This is a 2 by 3 matrix. 2 rows, 3 columns. This is what it is. Now, can any one of you tell me, because I told you this is something which has to be understood. And because we will be doing throughout, whenever we are doing matrix and determinant, we will be multiplying them. So first of all, the thing is that how you get the order without multiplying the matrix. And if you have the order, then how the elements will be drawn and how the elements will be written. Any one of you can tell me or can explain me how this multiplication has been performed or it will be done. Any one of you who can tell me. The solution, the question is in front of you. Can any one of you can answer my question? How the multiplication has been done? Unless and until you speak, how you will be in a position to understand it. The solution is in front of us. Don't worry, don't be afraid of just whatever you have understood. Just let me know. Any one of you. Or you want me to repeat it once again?
Yes, repeat it once again.
Okay, so why are you afraid of saying that thing? Because I know this is not that easy once unless and until you understand it. Once you understand it, it will be easier for you. Now, the question is in front of
Okay.
you. That is matrix A is a 2 by 2. This problem normally occurs when I can't see you that you are having pen and paper with you. If you have pen and paper with you and the solution I'm telling you, it will be easier for you to understand. Now, no problem. Again, I request you to have a paper and pen with you. Matrix A is in front of us. That is 135, 5 minus 1 minus 1. First of all, write its order. Its order is a 2 by 3 matrix. Now the question arises why it is a 2 by 3 matrix. It is a 2 by 3 matrix because it has 2 rows and 3 columns. First part is over. Move to matrix B. We can see 9 elements. It is having 3 rows and 3 columns. That means it is a 3 by 3 matrix. Now, when we will be multiplying a 2 by 3 matrix with a 3 by 3 matrix, we will be getting a 2 by 3 matrix as the answer. The arrow shows how we got 2 by 3 matrix as the answer. It has been told to you that when multiplying two matrices, the number of columns of the first must be equal to number of rows of the second matrix. You can see that in the first matrix there are 3 columns, and in the second matrix there are 3 rows. That means we can multiply it. Now the question arises, what will be the answer? I said there will be 6 elements. Now the thing is that what will be those 6 elements? When I will be multiplying, it will be C11, C12, C13, C21, C22, and C23. We cannot have C31, C32, and C33 because we don't have the third row in the correct. All the elements of row 1 will be multiplied to the elements of row column 1. That means 1 will be multiplied by 0 plus 3 will be multiplied by 5 plus 5 multiplied by minus 1.
Minus.
So when we will be solving it, we will be getting 15 minus 5, that is 10. You can see over here, it is written here, this 10. Secondly, what we will be doing, we will be multiplying these 3 elements with these 3 elements this way. I told you we will be moving this way, here to here and coming down. Left to right, coming down. Left to right, coming down. So left to right and coming down with C1, 2. First row, second column. 1 into 1 plus 3 into 2 plus 5 into 2. That is 70. 1, 3. Left to right, come down. 1 into 2 plus 3 into 1 plus 5 into 1. That will be 10. Here it is 10. Now, second row, left to right, top to bottom. 5 into 0 plus minus 1 into 5 plus minus 1 into minus 1. That will be minus 4. Left to right, top to bottom. 5 into 1 plus minus 1 into 2 plus minus 1 into 2. That will be 1. 5 minus 4. That will be 1. Left to right, top to bottom. 5 into 2, 10. Minus 1 into 1 plus minus 1 into 1. So 2 and 10, 8. 10 minus 2 is 8. Whatever the values you have found over here has to be written in this order. Same order. Same as this order. Again, you will be getting 2 by 3 matrix. 2 rows, 3 columns. Easy, eh? Now see to it, doing different operations at a time. A different method of showing how the multiplication is done. You have a matrix A. This is a 2 by 2 matrix, and B is a 2 by 2 matrix. That means your answer will be a 2 by 2 matrix. You can see that there are two rows. So how many columns are there in A? Number of columns in matrix A. How many columns are there in matrix A? How much? How many columns are there in matrix A? Where is matrix A? This is the matrix A. And how many columns are there in matrix? How many columns are there in matrix B?
In both of them, there are two columns.
Okay, that's fine. When you will be multiplying a 2 by 2 matrix by a 2 by 2 matrix, your answer will be a 2 by 2 matrix. Now, how that 2 by 2 matrix will come? See to it. We will be multiplying 2 by 1 plus 3 into minus 2. This green sign is of for elements of matrix B, and yellow sign is for elements of matrix A. You can see how these are multiplied. I said it will be multiplied this way: left to right, top to bottom, left to right, top to bottom, again left to right, top to bottom, left to right, top to bottom. In the second row, it will be left to right, top to bottom. Here, again in the fourth, second left to right, top to bottom, and it is written as multiplied 2 into 1, 2, plus 3 into minus 2, minus 6, 2 minus 6 is minus 4. Similarly, you will be getting minus 6, minus 12, minus 18, minus 1, minus 10, minus 11, 3 minus 20, minus 17. Your answer is a 2 by 2 matrix. Now see to it. Here, without multiplying, we will be seeing that how matrix order is found. When you are multiplying a 1 by 2 matrix by a 2 by 1 matrix, your answer will be a 1 by, you can see 1 by 1, 1 and this 3 by 2 matrix by a 2 by 3 matrix. Your answer will be a 3 by 3 matrix. See how we get this. The most important part to understand the line. How to calculate that 1 by 2 uh, 2 by 2 matrix is multiplied by a 2 by 2 matrix. It will be a 2 by 2 matrix. If 2 by 3 matrix is multiplied by 3 by 2 matrix, 3 by 2 multiplied by 2 by 3 will be a 3 by 3 matrix. Is that clear?
Yes.
Okay. You can see the screen.
Yes, yes.
Okay. Now see, there was some error with the connection. Now you can see how a 3 by 3 matrix is multiplied. When you are multiplying a 3 by 3 matrix, its answer will be a 3 by 3 matrix. What I said, left to right, top to bottom. Now you can see, just see this element. Left to right, multiplied by 4. That means AJ plus BM plus CP. Here it is. Always move like this. This with this, then this with this, then this with this. This will be this line. When you will be multiplying this with this, it will be third row. K plus H M plus IQ. Here it is. The last one will be left to right, top to bottom. GL plus HO plus IR. Got it? Have a look at it. Now see to it. Same method is being followed over here. How the multiplication of two matrices of the same order is being performed. Now see to it. This is a 3 by 3 matrix and the matrix P is by 3 by 3 matrix. One will be multiplied by 1, then 1 will be multiplied by 2, and then 1 will be multiplied by 3. The same method what was shown to you over here.
Yeah,
You
right.
can see
Well,
these Left to right will be multiplied by top to bottom.
On that
Left to
one,
right multiplied by top to bottom. Mr. Saeed, please
Hello?
mute yourself.
ما هو الميت أنا سكنا زينك شو ذي أنا أقول لك.
And in the third column, it will be this multiplied by this. 1 plus 2, 3, 3 plus 1. Similarly, 2 will be multiplied by 1 plus 2 multiplied by 2 and 2 multiplied by 3. That will be 2 plus 4 plus 6. That will be 12. In the whole row, you will get 12. And in the third one, you will get 18. 3 into 1 plus 3 into 2 plus 3 into 3. So you can see how the matrix of 3 by 3 order is being performed. Answer will be a 3 by 3 matrix. Is that clear?
Yes.
You have to move from left. You have to move from left to right and top to bottom for each row and each column once. Now, some more properties. For two matrices A and B, if A and B and B and A are both defined, then it is not necessary that they are equal. In matrix, we cannot say that 1 to 2 is always equal to 2 into 1. Here you can see that we have a matrix of 2 by 2 order A, and matrix B is again of order 2 by 2. When you are multiplying A by B, you are getting this matrix 10, 14, minus 1, 0. And when you are multiplying B with A, the order is reversed. You are getting 5, 1, 11, and 5, which is not same as that of AB. That means in matrix it's not necessary that always A and B will be equal to B and A. Now you have two matrices A and B. If A and B is equal to 0, it is not necessary that either A or B is a null matrix. You can see over here, if you are multiplying 1, 0, 0, 1, 0, 0 with 0, 0, 0, 1, your answer is when you multiply A by B, you get 0, 0, 0, 0. And straight away you can see that neither A is 0 nor B is 0, but you are getting an answer 0 in multiplication. Now the properties of multiplication. Associativity means matrix is associative if A, B, and C of order n, m cross n, n cross p, and p cross q respectively, then AB into C will be equal to A into BC. As far as distributive property is concerned, they should have to be the order matrix m cross n, n cross p, p cross q. Then A into B plus C will be equal to AB plus AC. Identity matrix. Identity matrix, as you know, it has been told to you that only diagonal will be 1, remaining all the elements will be 0. Now, how it is written? It is written as IN. You can see here, IN. N means order. I1 means 1 by 1, that is 1. I2 means a matrix of 2 by 2 of where diagonals will be 1. I3 means matrix of order 3 by 3 where there will be 3 rows and 3 columns. I would like to request any one of you who can explain me how this has been performed. Part 1 has been performed. Anyone from you? You have 3 matrices A, B, and C. You have to show that AB into C is equal to A into BC. Now I want that any one of you should tell me how this has been performed. All the steps and the methods is in front of you. Just let me know how it has been performed. Can any one of you tell me that how AB is resolved? How we got the product of A and B matrix? And the product of AB matrix is 5 minus 6, 11, and minus 12. Any one of you? There are 2 matrices A and B, 1, 2, 3, 4, and matrix B is 1, 0, 2, minus 3. When they are multiplied, you get an answer of 5 minus 6, 11, minus 12. My question is, how you got this matrix? Nobody can answer it. Am I audible to you?
Let's try fifth column.
Bilal, can you answer it? How we got matrix product of AB?
From left to right and up to down.
Well, reply to it what you have understood.
I have been done.
How the product of matrix A and B will be obtained? When your matrix A is 1, 2, 3, 4, and matrix B is 1, 0, 2, minus 3. How we got this matrix 5 minus 6, 11, minus 12? This is simple as multiplication of 2 matrices of the same order. That is 2 by 2. The answer will be a 2 by 2 matrix.
Matrix A, we have 1, 3,
1,
B, 1, 0.
1 will be multiplied by what?
The matrix of B, 1, 0. Then repeat it again.
From where you are getting 1, 0? I'm asking you, 1 of matrix A will be multiplied by which element of matrix B?
1, 0, 2, minus 3.
Remember, the first element of 1 will be multiplied by element 1 of column 2, matrix B. That is 1 into 1 plus 2 into 2. That will be 5. 1 into 0 plus 2 into minus 3. That will be minus 6. Again, you will get 3 into 1 plus 4 into 2. That will be 11. And the fourth one will be 3 into 0 plus 4 into minus 3. That will be minus 12. I told you, you have to multiply from left to right to top to bottom. Similarly, we will be performing AB into C. We have AB from here. This is AB and C is this. C is this. Multiply this with this plus this into this. That will be 5. Then 5 by into minus 1, minus 5 plus minus 6 into 1. That is minus 11. Here it comes minus 11. Now 11 into 1, 11. 0 multiplied by any number is 0. That means 11 plus 0 is 11. Then comes your 11 into minus 1. That is minus 11. And 3 and minus 12 into 1. That is minus 12. That is minus 23. Here it is. Now, we have A, B, C in the same order as this. Now, we will be, first of all, we will multiply B and C together. That means we will be multiplying these two. Here it is. This will come out to be 1 minus 1, 2 minus 5. This product will be multiplied by A. That means A will be multiplied to this product. You will get 5 minus 11, 11 minus 23, which is similar to the top what we have calculated over here. That means A into AB into C is equal to A into BC. This has been proved. Now, what is this? First of all, we will calculate B plus C. B plus C will be 2 minus 1, 2 minus 2. Here it is B plus C. Now multiply this A with this sum. Your A is 1, 2, 3, 4. And your B plus C is this. You get 6 minus 5 is 14 and minus 11. Now calculate. Leave it. We will be moving to right hand side. What has to be proved? AB plus AC. First of all, find AB. Here it is AB. AB is 5 minus 6, 11 and minus 12. AC is 1, 1, 3, 1. What we have to calculate? AB plus AC. When you will be doing AB plus AC, this will look somewhat like this, which is equal to this. What you got at the top? You got at the top this one. So this one and this one are same. So we can say that A into sum of B plus C is equal to AB plus AC. Third one, I means identity matrix. A matrix is of 2 by 2 matrix. That means identity matrix will be matrix of order 2, which will be having 2 rows and 2 columns, and the diagonal elements will be 1, and remaining all 0. Now when you will be multiplying 1 with A, yani identity by A, you will be getting A. And when you will be multiplying A with identity, again you will get A. That means AI is equal to IA is equal to A. What is meant by transpose of a row? You are aware of horizontal elements are rows and vertical elements are columns. In transpose, rows are converted into columns. What is done? In transpose, rows are converted to columns. And it is denoted by A apostrophe A star, A dash, anything. If you are transposing 2 times, A dash to A dash, A dash to dash, you will get A. When you are multiplying with any scalar quantity, so it will be K times of A transpose. If A plus B transpose has to be calculated, then we can write it A transpose plus B transpose. identity transpose is equal to identity. And similarly, if AB transpose is there, then B transpose into A transpose has to be done. Now we will see. A is equal to 2301. B is equal to 3421. And identity matrix will be 1001 because we have two rows and two columns in the rest two matrices, that is A and B. So I will be of the same order, 2 by 2. Diagonal elements will be identity and remaining elements will be 0. So, and what will be the A value of A transpose? A transpose, that means rows will be converted into column. What is row? This is row. So this is 2, 3. Your A transpose will be A2, A3, 2, 3 and 0, 1. Here it is. And again its transpose, that will be the original matrix. A trans is 3 A's multiplying 3 by all the elements. It will be 6, 9, 3, 0. 3 times of A transpose. 3 times of A or then its transpose. This we have calculated 3A. What will be the transpose? This row will come into column. So it will be 6903. Here it is 6903. Okay. 3 times of A transpose. It will be this one, which is 3A transpose. Now, how to calculate A plus B? Add 2. Because they are of the same order, they can be multiplied. When you will be adding matrix A to matrix B, you will be getting 5, 7, 2, 2. 5, 7, 2, 2. Then what is A plus B transpose? Where is A plus B? Where is A plus B? A plus B will be 5, 7, 2, 2. And its transpose will be 5, 7, 2, 2. A transpose plus B transpose. Do the transpose of A. That will be 2, 0, 3, 1. And B transpose will be 3, 2, 4, 1. Here it is. Then add them. It will be 5, 2, 7, 2. Then comes your transpose. This has been done. Here it is. A plus B transpose. Then you can see AB. We have to multiply AB. A is a matrix of 2 by 2 and B is a matrix of 2 by 2. You will be multiplying, you will be getting an answer of 2 by 2. And its inverse, its transpose will be, rows will be converted to column. So it will become 12 to 11 bar. Similarly, we will be calculating B transpose into A transpose, which will be similar of AB transpose. Systematic matrix. A is a matrix, 3 by 3 matrix. Is systematic matrix will be on transformation. On transformation of A, it will become A. Or normally this doesn't happen. Your skew, how to write skew symmetric matrix. This is skew metric only if A transpose is equal to minus A. For example, you have this matrix. As you can see that the elements are 0. What will you do? First of all, calculate A transpose. After calculating A transpose, you will get 0 minus 5 minus 4. That means rows will be transformed into columns. 5, 0, 1, 4, 1, 4 minus 1, 0. You take common from it. As soon as this minus common is taken 3 times, your answer will be again in with y. So what will you do? Its transpose will be convert this row into column. You can see that it will become 0, 5, 4, minus 5, 0, minus 1, minus 1, minus 4, 1, 0, which is negative of A. If this condition exists, then that matrix is known as skew symmetric matrix. Under skew symmetric matrix, what happens? A transpose is equal to minus A. Then comes your orthogonal matrix. Orthogonal matrix is A transpose. A into A transpose is equal to A transpose into A, and which is equal to identity A into A transpose is equal to A transpose into A is equal to identity matrix. If you see to this problem, this is A. A transpose will be, this scalar number will remain as it is and this will change. The rows will be converted to column. 1, 2, 2 will come over 1, 2, 2, 2, 1, minus 2, 2, 1, minus 2, minus 2, 2, minus 1. This will come to this. Now multiply these two. This will become 1 by 9 and this has to be resolved. When you do it like this, you will get this. Take 9 common, 9 by 9 is 1 and remaining this will become 1 and all the elements apart from the diagonal elements are 0. That means we can say that it is an identity matrix. Orthogonal matrix are those matrices in which A into A transpose is equal to an identity matrix. Now we move to determinants. We can say that it is determinant value is a value, a number. Or we can say that we are finding out the value of the matrix. To every square matrix, we can assign a number called determinant. It is represented as mod of A. And the order will remain same. A11 means first row, first column. A12 means first row, second. And similarly throughout, every part can be used. Now see very carefully what I am telling you. Are the 4 elements. A11, A12, A21, and A22. We have to find that we will be multiplying this way. See to it. This minus this. This minus this. That means A11 into A22 minus A12 into A21. If you have a matrix of A, B, C, D order, then your determinant value will be A into D minus B into C. If you have a 3 by 3 matrix, see very carefully what I'm going to tell you. Pick up this red one is the answer. What we have to do? Pick this A11, write it over here. Write two vertical columns and remove this row and this column. You will be left with this part, these four values. You can see these four are written over here. I'm repeating it. Pick this element A11 here, remove this row and this column. You will be left with these four elements. These four elements are this. The first one is with plus sign. The second one is automatically minus sign. Bring A21. You can bring A21 or A12. That doesn't make any difference. Here I have taken A21 and at the top I have taken A12. When I will be taking A12, what I will be doing? I will be removing this and removing this. So I will be left with this and this. And in the third one, the first one is plus, second one is minus, third one is plus. That will be A13 into remove this and remove this. You will be left with these four values. So it will become A21 into A32 minus A31 into A22. This is what is written over here. This can be 0, this can be plus 1, or this can be minus 1, or with any number with plus and minus sign. And it can be 0. Now see to it, how it is used. First one is, see the minus sign in second. Whatever A12 is, if it is plus, it will be minus. And if A12 is minus, this sign will change to plus. When you are taking opening across A11, so considering A11, you will remove E12 and A13 from the row and A21 and A31 from the column. You will be left with A22, A23 and A32 and A33. First one is plus, second one is minus. Minus A12. That means you will be removing first row and second column. That means you will be left with A21, A23 and A31, A33. Second one is minus, the third one is plus. So you will be removing first row and third column. In that case, you will be left with A21, A22 and A31, A32. Now, what are the properties of determinant? The determinant of a square matrix is interchanged when its rows and columns are interchanged. Now you can see that rows have been converted into columns and columns have been converted into rows. So what will happen? Matrix value will not change at all. Suppose your original matrix gave the determinant value as 30. So your determinant which is obtained after transpose, you will get the same value. Second one is the determinant of a square matrix obtained by interchanging the two rows or two columns is negligible to the given determinant. When you are changing rows with column, so you have to introduce a minus sign, a negative sign in front of the matrix. If rows and columns are being interchanged, the determinant value will be multiplied by -1. If two rows or two columns of a determinant are identical, the value of the determinant will be 0. You can see that second row and third column are identical. Its value will be 0. If all the elements of row or column is a square matrix A are multiplied by a non-zero number k, the determinant of the new matrix is k times the determinant of A. Suppose in A we got 20. So when we will be multiplying this matrix by 4, so that will become 20 into 4, that is 8. If all the elements of two row column square matrix A are multiplied by non-zero number k, the determinant of the row is k times the determinant of A. Suppose we see that we get 56 by this solving this matrix, and we multiply it by 2. It will be 56 into 2. It will be 112. If elements of any column as sum of the two elements, then each determinant can be written as. Now see to it. This is the question. What is happening over here? In general form, if this is minus 5, first of all, how it will be removed? It has been removed. And it will be solved. First of all, the thing is that how it will be split. Split means factors. Minors and cofactors. Minor of an element Aij minor of element Aij of the determinant of matrix A is the determinant of K1. In the ith row and jth row denoted by Aij. I will show you how it is done. Now see, you are given a matrix. This is a 3 by 3 matrix. You have to find a minor of 32, A32. That means A32 means third row, second column. Third row, second column. What you are left with? 7934. Here it is. 7934. Multiply it, you have to get the value, multiply from top to bottom, minus top to bottom. 7 into 4, minus 9 into 3. 7 into 4 is 28, and 9 into 3 is 27. 28 minus 27 is 1. And similarly, you have to evaluate 2, 3. 2, 3. 2, 3. You are left with 7562. 7562. Multiply 7 into 2, 14. Minus 6 into 5, 30. 14 minus 30 is minus 16. Here it is. And if you have to find cofactor, multiply minor with minus 1. Now you can see, for the matrix, find out the cofactors of all the elements of the corresponding determinant of the matrix. This matrix is given to you. First of all, A11. Remove first row, first column. A11, if you remove one first row and first column, you are left with minus 6. And first row, second column. First row, second column. Minus 9. minus 9 plus 2. Minus 9 plus 2 is 7. 3, 3. Third row, third column. Third row, third column. So 2 minus 18. Matrix of 3, 2. First row, third column. First row, third column means 3, 2 minus 2, 0. So it will be 0 minus 4. That is minus 4. A21. Everything has been resolved. A31, A21, A22, A23, A31, A32, and A33. Three values have been found over here, and six values over here. So we have got the 9 values. Now, use of Cramer rule in determinants to solve system of linear equations. How this is drawn and what does this mean? Somebody understand it. If you have a matrix of 2 by 2, that means you can see that here are two equations, ax plus by equal to e, and second equation is ax plus by equal to x. So this is the formula for evaluating the values. X is equal to delta x by delta, and y is equal to delta y by y. I will show you how these values have been applied. You can see that your original matrix, take the matrix in the same way. It is going same as you have to take the same matrix, the same order in which the original equations are taken. Now I will pick up the coefficients A, B, C, and D. Here it is A, B, C, D. A, B, C, D. Your delta x, replace this AC, A and C, by E and F. Rest, this column will remain as it is. And when you are talking about delta y, so just remove this. Delta y remove करना है तो आपको, that means you have to remove AC. You will get delta y. For this you have to remove this y part, and it will be replaced by E and F. Here you are. Now this method is applicable only when delta is not equal to 0. And if in case delta becomes 0, we cannot apply this. If for 3 by 3 matrix, take up the elements A11, A12, A13, A21, A22, A23, A31, A32, A33. एक part is completed now. Delta x1, replace all the elements of x, these coefficients, by b1, b2, b3. Similarly, remove this y and place y1, y2, y3. Third one, similarly, replace this and add b1, b2, b3. Your delta 1 will be delta x1 upon delta x2 will be equal to delta x2 upon delta 3, and y the third one is z, that is x1 equal to delta x3 upon a. If here also, if d is equal to 0, we cannot solve it in this way. We have to note that matrices are enclosed with square brackets, while determinants are denoted with vertical lines like this. A matrix is an array of numbers, but its determinant is a single number, that means its value. For any system of linear equation, if delta x is equal to 0, is not equal to 0, the system has unique solution and system consistent. If a is equal to 0, then delta 1, delta 2, delta 3 till n are also equal to 0. Then the system has infinite solution and system is inconsistent. System is consistent. Third one is if delta is equal to 0. If the set of at least 1, that means delta 1, delta 2, delta 3 or n, equal to 0, then the system has infinite solution and system is consistent. If delta is equal to 0, and at least one of delta 1, delta 2, delta 3, delta 4 is not equal to 0, then the system has no solution and system is inconsistent. Now we will see whatever has been discussed, how it is solved. You are given three equations. X minus 4y minus z equal to 11. 2x minus 5y plus 2z is equal to minus 39. Minus 3x plus 2y plus z equal to 1. Pick up the coefficients in the same order the way it is written. Order, sequence, nothing can be changed. So we will form the matrix 1, 4, 1 minus 4 minus 1, 2 minus 5 plus 2. And the third one is 3, 2, 1. How to open this? We start from this corner. 1 into, remove this, minus 5 minus 4 minus 9. Here it is. First one is plus, second one is minus. You have minus 4, it will become plus 4. Remove this and this. You are left with this and this. This will be 2 minus 8 minus 6. We are talking about 4, 2. We will be moving this and this. 1 minus 15. How this is? 2. No, when we are talking about 4, so it will be minus 4. This and this gone. 2 into 1, 2. Minus or minus 6. 2 plus 8. Okay, third one is minus 1. This gone, this gone. You are left with this. 4 minus 15. 4 minus 15 is minus 11. These are the values. You get 34. This is the value of determinant. Now, that means delta is not equal to 0. Then we can apply the formula. X is equal to delta x upon x. Delta y equal to y upon delta y. Delta z is equal to delta z into delta. So delta x1 will be, we will be replacing these values. We will be replacing column 1 by 11, 39, 1. Here it comes. Similarly, for x2, we will be replacing these values of x2 by 11, 39, and 1. And in the third case, we will be replacing this by a now on solving, you will get minus 34 and your delta is 34. That means minus 34 upon 34 is 1. Y is equal to delta x2 by delta. That is minus 70 by 34, that is 5. Z is equal to delta x2 by delta. That is 272 by 34, which is equal to 8. Now, we have found the value of x, y, and z. X is minus 1, Y is minus 5, and Z is equal to 8. To verify your answer, whether you have computed it correctly or not, just place these values in any of these three equations. X is equal to minus, suppose I am putting it in equation number 1. X is equal to minus 1, minus 4 into minus 5. That is, minus 4 into minus 5 is 20. 20 minus 1 is 19. 19. And this is minus 8. What will you get? 19 minus 8 is how much? 19 minus 8. Can you tell me 19 minus 8? I'm audible to you? Am I audible to you? How much is, when I'm putting this x is equal to minus 1, y is equal to minus 5, z is equal to 8 in this equation, what I'm going to get? Minus 1 plus 20. It is 19. 19 minus 8. 19 minus 8 is how much? Is the slide visible to you? Nineteen minus 8 is 11. That means this answer is correct. Whatever we have calculated is correct. Any questions from anyone? Because I won't be moving further because this is that inverse, unit 3, inverse of matrix is a new topic. So I will be starting it in the next class. Do you have any question? Okay, anyone else? No, no, I won't be going further today. We will be discussing it the inverse in the next session, next class. But whatever I've discussed today, is that clear to you? Because this is the basic from where we have to start. Okay, so can we conclude today's session? Okay. I will concluding this session, and we will be meeting on the next session, which has been the schedule is with you. So we will start with inverse of the matrix in that session. Till then, bye bye.